So this discussion is on binary trees. It's a follow-up on the previous session where we discussed normal trees. So now we will do a discussion on binary trees. Now a binary tree is exactly the same as a normal tree, but with the difference that the nodes can only contain 0, 1, or 2 children. We refer to these nodes as the left and right child. So for every node, in this example 14, has 2 children, 19 and 15. 19 will be the left child and 15 will be the right child. Then the next one, 19 is also a tree, it's a sub-tree, but this tree is a child of 14. So this tree will contain 2 children, 23 and 6, with 23 being the left child and 6 being the right child, etc. So this is a binary tree, a tree where every node contains only 2 children. So this is the way in which we implement this. So you will remember previous time with normal trees, we had the value, but then we had a list of children. Now we don't have a list, we have only 2 children, referred to as the left child and the right child. Note the type of these children. They are trees in itself. So this is a recursive definition. That is B tree for binary tree. It's generic, so the data element can be of any type. So there we can have any type of thing in the value, but then there are 2 trees in itself, and each tree also will be generic and will also have a value. So note this way for the data members of a binary tree class. So the constructors, as previous time, we have more than one constructor, more than one possibility. In this case, for the simple one, we will in comes a value, assign that value to the data member value, note the uppercase, lowercase difference, and then we will instantiate the left child and the right child. Actually, this is no instantiation, we assign a null, so we could just as well leave this out. And then when we create the tree, so let's go to the example in Visual Studio. When we create the tree, we will link the nodes afterward. So if let's do this on this side and take my example and put it on, where's my example now? Yeah, this one. That is the binary tree example. So first of all, I create a tree with a value of 14, and of course this name of the tree can be anything. I just named it to be convenient so that I will remember what the value is in there, but of course it can be anything. So we create separate trees. Each node will be a separate instance of tree, and then we put a value in there, so the value goes through the constructor, and this is done by the class user. And then afterward, after we have created all the nodes, we can then connect them. So the binary tree 14, the root, takes left child BT19 and right child BT15. Look at this example again. BT19 in turn takes left child BT23 and right child BT6. Those are these two, etc., etc. So this is done by the class user, and this is the way in which we can create a tree using the first constructor. Now the thing that will be returned is the root. So this will be returned. BT14 is the tree that will be returned because we only need to return the root. The other nodes can all be accessed from the root by going from the one to the other. So the class user will only eventually just keep track of the binary tree of the root. So binary tree in this case here will be the thing that would have been returned from there. So this will be the root. And from the root, we can go through all the other nodes as necessary with various ways of traversal. The second constructor is the one that takes the value, but in addition also takes the left and the right child as parameters. So instead of assigning null there, we assign values to the left child and the right child. And then the class user will have to, do I have an example? Yes, there's create 2 example there. So down here should be create 2. So in this case, Note it's a long, I should open this. It's a long recursive embedded nested string. So the binary tree has a value of 14. This one in turn has two children, 19 and 23. But 23 in turn has two children, 6 and 10. And if we look at the picture again, try to visualize this example. How can I now put this all on the picture while we are having that thing? So let me see if I can do this. Yes, now you can see everything. So 14, no, that's gone. I may not click. 14 is the root. It has two children, 19 and 15. They go underneath each other. 19 in turn has two children, 23 and 6. 6 in turn has two children, 10 and 21. So in this way, we go deeper and deeper and deeper into the nested structure, and you will understand that this can be confusing. So this is actually an easier way to do it, but just create the separate trees one at a time, and then later afterward we link them by assigning the children. So yes, there are two constructors possible there are two constructors possible, and this one, assigning null, is actually the easiest one of the two. So let's look at the next section, which I believe will be the traversal. Yes. Now the thing with the binary trees, as I mentioned, it is a tree. As any other tree, it's a tree. But what we now have extra is extra traversal strategies. The previous two traversal strategies, the depth first traversal, and I should change that. The depth first traversal and the breadth first traversal, or searching. Let's change this so that we do not confuse ourselves. Even it's the same thing. It's just with the search we stop when we find the node, and with the traversal we go right through to visit all nodes. With the depth first and breadth first, as we had previously, we go as we mentioned. But now we have two extra traversal strategies, three extra, referred to as pre-order, in-order, and post-order. Now, pre-order is a root left-right, in-order is a left root right, and the post-order is a left-right root. Now, this might sound confusing for the start, but just bear with us, it will become clear just now. If we take our example, and I want to add a little line here. So if I go to shapes and I put a line there, and I take this line and I slide it from left to right across the tree, that will then constitute an in-order traversal. So an in-order traversal will be 23, 19, 10, 6, 21. Okay, the tree is not drawn correctly because it's first the 21, then the 14, then 3, then 5. So draw the line from left to right. Make sure that you don't have this thing. This 21 should be to the left of the root there. And then you will have the correct order of nodes if you visit the tree in an in-order way. So as I said, there are now 5 different strategies. Actually, 2 of them are exactly the same. You get the same answer. The depth first and the pre-order will give you the same order of nodes. Depth first, just to revise from what we have in the previous video session, is starting from the root and go as deep as possible. And those on the same level, we visit from left to right. So it's 14, 19, 23, 6, 10, 21, 15, 3. That's a depth first. A breadth first will be from the root and then on all levels from left to right. So it's 14, 19, 15, 23, 6, 3, 10, 21. That's a breadth first. And then an in-order traversal will be 23, 19, 10, 6, 21, 14, 3, 5, 15. And then the last one, maybe the most complicated one is the post order, where we will visit the nodes in a left-right root order. So first the left one, then the right one, and then the root for every subtree. That will give us eventually this order. So you can look at the example, put the example on the screen in front of you, and then go through this and understand the post order. Now, the algorithms are actually, all three of the extra ones are actually exactly the same. And there's just the order in that we put things in the private version. As previously, we have two methods, a private and a public method. So the public one is called from the class user side. That one in turn will call the private method. So this public one does not have parameters, and it returns a list of t, which means it returns a list of values saved inside the nodes, not the entire node. And then this thing will call visit pre-order the private one, which will have a parameter list of nodes and returns nothing. This visit pre-order is private. This is recursive. It will be called from inside itself again. So when we start off with a public one, we start off with an empty list. We call this visit pre-order private version with this list. When this private version is done with its job, this list nodes in the private will have some values which will be returned, and the class user can then use this and display the nodes or do whatever he wants with it. And that will then be inside a list of t. The private recursive version, and now this is where the three different traversal orders are exactly the same, but for small changes. So we have 1, 2, 3 elements. We visit the root of the subtree, then we visit the left child, then we visit the right child. So when we visit the root of the subtree, it means that we take the value from the root, from the thing that has called this, and we add it to the list of nodes. And then if the left child is not null, we call this method again recursively. If the right child is not null, we call this method again recursively. And you will remember in the previous version for the normal depth first, we did not do these things separately. We have a list, so we just step through all the list through all the nodes in the list in a for each loop. So it's exactly the same that we did previously, but instead of stepping through a list and visiting the nodes in a loop, we do now visit the two nodes, each one individually, because it's simple to just visit two nodes. It's a limited number of children, so we just do it separately. But of course, we have to check. If there's not a left child, then we cannot call the thing recursively. And this recursion will then stop when both the left child and the right child is null. So that will mean that we are at the bottom of the tree, we have leave and with no children, and this recursion will stop. So now if we go to the if we go to the in order and post order, you will see that they are again exactly the same. The only difference is that these order of these things differ. So for in order, we have first the left child, then add the node to the list of nodes, and then we visit the right child. For the post order, we go recursively into the left child, then recursively into the right child, and then we visit the node itself and add it to the list of nodes. So if we go to the program, there are my depth first, as previously, no difference. That is my breadth first, using a queue, as previously, no difference. And this is my in order, constituting of two separate methods, a public and a private one. My pre-order, two different methods, a public and a private one. And my post order, two different methods, a public and a private one. The public ones are, in all three cases, are exactly the same. The public ones, no difference. But the private ones, the visit in order, visit pre-order, and visit post order, private methods, they only differ with respect to the order in which these three elements are visited, are done. So the left child, right child, and the root are just visited in different orders for these three different search strategies or traversal strategies for binary trees. So that was my discussion on binary trees. I don't think I left out anything here. So what I want to do in the following video is to go to ordered binary search trees. So we will do that in the next video.